Okay, welcome back everybody. This is going to be Unit 1, Section 2, covering a little bit on the history of geology. And just real quick, what we're seeing in the background here, this is a map. Might be able to tell right away that this is actually a map of England. You might take a moment to think about what it is that we're mapping here, and notice that the shapes on this are not random, even though it looks a little random at first. We notice that this layer here kind of matches the shape of the coastline. This one here kind of matches the shape of the coastline as well. And they all do, moving inward until we get to these in the center, sort of blobs. And then we get a little bit more that looks like the shape of a coastline. And then we get something which looks completely unrelated from all the other material. Moving on. First instance recorded of something we would call geology. From the 4th century BCE, Aristotle made observations on the slow rates of geologic processes, something like observing sand grains entering the sea. And just realizing that when it comes to something like sand grains entering the sea, that you could sit there and watch it for your entire lifetime and not really notice too much of a change. It's really not going to look any different at the end of your life than it did at the beginning. The idea here, these processes are very slow. Moving quite a bit ahead here to the Middle Ages in China, Shin Kuo, who identified a record of climate change for the first time. He noticed that there was petrified bamboo underground in a location near him which didn't grow bamboo anymore. So the idea is, well, obviously there used to be a different climate in this area, yeah, because the bamboo grew here however many tens, hundreds, thousands of years ago, but it doesn't grow here now. So this is our first instance recorded of climate change. Moving ahead to the 17th century, this is Nicholas Steno, one of our founders of geology. And part of his contribution, it might seem like a no-brainer, but hey, he was the first one to write it down. The Earth is broken into layers. We have horizontal layers of rock, each of which has the same composition. It's made of the same material throughout. Going to Germany now, Kant was one of the first ones to question the age of the Earth. And this turns out to be something of the original question for geology. This is the question essentially that birthed a lot of geology as a science. How old is the Earth? Well, moving ahead, we have James Hutton, who essentially said that, we can answer some of these questions, like how old is the Earth, with uniformitarianism. So the idea here is that in order to have an idea about what the past of Earth is like, rather than being too creative with things and trying to imagine a place that was vastly different from what we see today, instead, what we should do is look at the processes that are going on. So earthquakes, volcanoes, rivers, glaciers. We should look at how those are happening today. We should look at the state of the Earth today, and then we should work backwards using those in order to figure out what the Earth might have been like in the past. William Smith, see here, lovely man, found that fossils, there we go, there's William Smith, found that fossils were a highly effective means of distinguishing similar rock layers. So this rock layer over here looks like a massive gray blob. This one over here is also a massive gray blob, but the fossils in the two are different. This one has fossilized teeth, very sharp and jagged shapes. The one over here has small round objects in it. And it turns out that using these and intuition, and you can produce a geologic map, which is actually what we saw on the first slide. That is the first geologic map ever produced. Kelvin actually was one of the first to try to get a quantitative answer, a number for how old the Earth was. And what he used is something you might think of as the loaf of bread theory. So the idea is you compare the Earth to a loaf of bread. If we know how hot the oven was, we know how hot the loaf of bread is now, and we can measure how fast the loaf of bread is putting off heat and cooling. We put all those together and we might be able to find the missing piece of information, which is how long it has been since the bread came out of the oven. In other words, how long it has been since the Earth was removed from whatever initial, very hot material it came from. Moving on, very important, we have Alfred Wagner proposed the idea, the theory of continental drift. So this theory suggests that shapes on the geologic scale of the Earth, looking at different continents, that these shapes fit together because, just as you might have imagined, those continents were sutured in the past, and then for whatever reason they have broken and ripped it apart and spread further and further ever since. Stay tuned for section 3, going to be on Earth's place in the solar system.